Hey everybody, welcome to this lecture. We're going to be talking about acids and bases. So I've already mentioned, or not mentioned, I talked about water in our last video. When water ionizes, it releases hydrogen ions, which are acidic, and it releases hydroxide ions, which are alkaline or basic. So an acid then is a solution that contains a high amount of hydrogen ions. So they release hydrogen ions when they dissociate, and they typically have a very sour taste. An example, hydrochloric acid releases hydrogen ions right there when it dissociates in water. Bases then, or alkaline solutions, have low hydrogen ions, and when they dissociate, they typically release hydroxide ions. Bases are also known as alkaline, and they have a bitter taste. So an example of a great base in water, if you put sodium hydroxide in water, it's going to release hydroxide ions. So bases tend to pick up hydrogen ions, and they can actually make the pH change by picking up hydrogen ions or by releasing. So different solutions, if they pick up hydrogen ions or if they release hydrogen ions, you can change the pH of a solution. So what is the pH then? A pH scale is the measure of the amount of hydrogen ions in a solution. pH scale ranges from 0 to 14. I'm going to go to the next slide because it shows a pH scale. So here we have 0. Hydrochloric acid is at about 0. And then you can move up to stomach acid is anywhere from 1 to 2 pH. As you move this way, you're becoming more and more basic. So pure water has a pH of 7. Blood has a pH of 7.35 to 7.45. And then as we move this way on the pH scale, we're becoming very, very alkaline. And so sodium hydroxide is very alkaline. Hydrochloric acid, very acidic. Sodium hydroxide, very alkaline. Does that make sense? If we move this way, then we're becoming more and more acidic. Sometimes the pH changes or pH changes can cause problems. And so we have buffers that help to maintain the pH within whatever range we care about. This occurs in laboratories if we need to have a specific pH, but this also occurs in our cells. Cells have to be able to maintain specific pHs, and so they have buffer systems. An example of a buffer system is the bicarbonate ion and carbonic acid buffer that's found in blood. So let's look at that system. Okay, so remember that blood has a pH between 7.35 and 7.45. Anything above 7.45 is considered alkaline or basic, and anything below 7.35 is acidic. All right, so we're showing just hydrogen and hydroxide, but think of if an acid is added to the blood, that's going to make our blood more acidic. What happens is the acid binds with bicarbonate ions, producing a less acidic carbonic acid. So this is carbonic acid. It's less acidic. That will raise our pH back to where we want it. But if a base is added to our blood, that makes our blood more alkaline or basic. So what happens is that base binds with carbonic acid, forming bicarbonate ions and water. Bicarbonate ions are less alkaline And so that will lower our pH back to where we want it to be. And so these help us to prevent any significant changes within our pH. I'm going to stop here, and in the next video, we'll start talking about organic molecules, okay? Bye.